Hey everybody, welcome to the Flip class. I know that everyone likes to see my dog London when he makes his little guest appearances before our videos, but today I think he's maybe a little busy. Or maybe not. Hey buddy, you want to teach some math? You want to teach some math? Okay. Okay, welcome back to the Flip class. Today we're going to talk about slope. No, not a ski slope. Slope and rate of change. Okay, first of all, let's start with rate of change. The rate of change of a function is the ratio that compares the difference between the two output values, to the difference between the corresponding input. So output to input. Okay? To make it a little bit easier, rate of change is the change in the y values over the change in the x values. Rate of change can either be constant, which means it's the same for the x and y values, or it can be variable, which means they are different. Okay? So let's check it out. To go from 0 to 4, you have to do plus 4. 4 to 8, plus 4. 8 to 8, plus 0. 8 to 6 is actually minus 2. Okay? We're starting with y because that's what we said first. The change in the y values. Okay? Let's look up here. 0 to 1 is plus 1. 0 to 3 is plus 2. 3 to 6 is plus 3. 6 to 8 is plus 2. Okay, now if we find the ratio, what we really want to do is we're comparing change in y, change in x. Okay, so we're going to start here, and we're going to do it this way. We're going to look at y to x. So first one we have 4 over 1. The second one we have 4 over 2, right? 4 over 2. Then we have 0 over 3, and then we have negative 2 over 2. All right? If I translate those, I'm going to translate them down here below. Okay? 4 over 1 is 4. 4 over 2 is 2. 0 over 3, of course, is 0. And negative 2 over 2 is negative 1. Those are all different. So, I know looks very sloppy now, but the rate of change in that example is variable because they were all different. Let's look at another example. Okay, let's check out another one here. We're looking for rate of change, so we're going to start with y. We have 1 to 2 is plus 1. 2 to 5 is plus 3. 5 to 7 is plus 2. 7 to 8 is plus 1. Now I want to point out, just because that's 1, 3, 2, and 1, just because those numbers are different, does not mean that this is variable. Okay, that's not how we get that. We have to compare the rate of change of y over the rate of change of x. Okay, so let's check it out. Plus 1, plus 3, to get from 1 to 4, to get from 4 to 6 is plus 2, to get from 6 to 7 is plus 1. You'll notice both 1s, both 3s, both 2s, both 1s once again. 1 over 1 is 1. 3 over 3 is 1. 2 over 2 is 1. I think you're getting the idea, and 1 over 1 is, of course, 1. Those are all the same. So the rate of change in that example is constant. It's the same every time. The ratio rate of change is the same every time. When we record data, especially if we're going, we've been talking about tables, charts, but a lot of times in those tables and charts you'll have data or information, okay? When we record that onto a quadrant like this, onto an XY axis, onto a coordinate plane, if you record it and the rate of change is variable, the line wouldn't look like this. Okay? If the rate of change is constant, then the straight line, like this one, is called the slope. Okay? Plus 1, plus 1, plus 1, plus 1. And we'll go into some more examples of this in the class, but the important thing is, if you have your x inputs, your y outputs, you've decided if it's constant, you've decided if it's variable. If it is constant, and you were to put that on the coordinate plane, x, y, and you would fill it all in, you would end up with a straight line. Okay, that's all I have for us for today. We're going to talk more about this even more in depth the next time I see you. Can't wait. See you then.